You're listening to Catching Wildfire, a podcast by the Public Safety Broadband Technology Association. I am Jeff Johnson, retired fire chief out of Tualatin Valley, Oregon, and past executive director for the Western Fire Chiefs. And I still serve the Western Fire Chiefs in making sure that we're educating our membership, working on technology and wildfire issues. I'm very fortunate to be joined today by Renny Vandeweg, who is at DTN Weather. He has spent, as the general manager, he has spent over 25 years focusing on weather intelligence and essentially communicating the weather status and predicted weather, solving weather peril and risks for not only their commercial customers, but also the general public. And then, of course, I have my normal sidekick, Kim Zagaras, better known to the world as Chief Z. As the FCC commissioner once dubbed him a national treasure. Chief Zagaras ran California OES for 18 years and also serves for the Western Fire Chiefs as a senior wildfire policy advisor. So, gentlemen, welcome today to Catching Wildfire. And Renny, it's so good to run into you. I could tell our viewers, Renny's one of those guys that can hang with firefighters, and I have tested the theory. And I am amazed by his depth of insight, and also he's just one enjoyable person in the business to make it better for us. So, Renny, maybe you tell us a little bit about DTN and how the company became involved in wildfire and public safety issues in general.
Absolutely. Well, it's an honor to be with you today, both of you, and great to see you again. I did get the chance to hang with the firefighters and had a wonderful night. Probably a story for a different podcast, but we had a great time together. DTN has a long history. We've been a company serving weather risk for over 40 years. It started out as a company solving weather prediction and forecast insights for aviation. And so we've been rooted in essentially being an important part of operational decisions where weather risk can impact safety, disruption, etc. Obviously, as time has gone on, we've expanded our capabilities into different perils and threats as they've evolved over that time period to include hurricanes, ice storms. And really, over the last 10 years or so, wildfire has become a front page of the newspaper topic for so many people. It's been interesting from my seat working in different industries such as utilities, public safety and emergency management, live events, to see how wildfire has become a more predominant topic. It used to be thought of as something, and you guys are very familiar being part of the Western Fire Chiefs, as a West Coast thing in the United States. And that just simply isn't true. We've seen wildfire risks start to spread to areas further east in the continental U.S. Of course, we could talk about Maui and the major fire that occurred there a few years ago. And so customers of all shapes and sizes have come to DTN to not just solve your traditional weather risk, is it going to storm, is there wind, but also to include the perils such as wildfire. And so that's an area where we've been evolving and continue to evolve each and every day.
So, for all of us rich kids that had a TV growing up, even going back to, the 70s, you could see a weather event on the East Coast happening. You could see a hurricane coming in. And then that evolved to 3 or 4 different companies laying down a track. And you could pick the one you believed in the most, but they were always close. This has got to be a different kind of thing. Like, that's slow moving, days out, and it's degrees of accuracy how accurate the track is. But this wildfire thing, I mean, it could start right now and you're in the game. How does that change what you do in these little microclimates? How does that instantaneous ignition and going from nothing to something in a hurry, how does that affect your analysis capabilities?
It's a real hard challenge to solve for, and I think you've hit it right on the head, which is this is a super fast evolving threat. And when you talk about degrees of accuracy, when you talk about wind direction and wildfire, if you're 5 degrees off, the spread is a different makeup and profile. So I think it's challenged us in a couple ways. Number one, we want to get out ahead of the risk days in advance. And so a lot of our customers are mostly looking at where are the environment or atmospheric conditions along with the dry fuels at the ground most conducive to have wildfire or wildfire spread should there be one. And so we want to get out ahead before there is a fire, just to simply say, we're in a setup here where wildfire, if it starts, could spread really rapidly. I think the amazing thing that we're watching unfold in front of us right now is this technological revolution with AI, smart technology capabilities. We have the ability to put cameras and satellite sensors and so many unique technologies out in areas we would describe as very rural or even hard to get to, but maybe high wildfire risk, and allow us to identify that first smoke or that first spark and start to get out ahead of it. And then in the weather forecasting realm, this AI technology is letting us forecast weather at really high precision and really high resolution versus what we could do even 3 to 5 years ago. It's becoming more cost friendly to model the atmosphere really intensely. And as a result, I think that's helping us make the fire spread predictions become smarter over time and continue to get improved to understand this wind, this dry fuel, where the fire is today. Here's where we think it's going to spread. And as a result, can communicate a lot better.
So in the public safety community, one of the difficulties of using AI is AI needs a database that it can search and reference before it starts to perfect its learnings therein. And you think about a lot of the, especially in EMS, but you think about a lot of the fire data and EMS data, the granular data is buried in some RMS system somewhere, and AI doesn't have a shot at it. So it's a little behind on our side, but I see how it could really change what you do. And you must open up your entire database one way or another to this in order to have it use it and refine it.
We do. We always say that weather is the original big data problem. We've been measuring with satellites and radars and these huge physical models, even going back to the 1970s and 1980s. And so as a result, that does allow us to have a pretty incredible history of data and also be on the leading edge. If you go look at any of the major cloud and tech companies, whether that's Microsoft, Google, Amazon, AWS, they always use a weather example to talk about the tech that they're doing. And so we found this out in many of the industries that we work in, that while our data may have a better history, it's often the specifics of the peril or the industry data that might be need to be digitized. Interestingly, you can use AI and neural networks to help kind of build backwards the data. And so you can artificially look backwards and try to figure out how the data is. But I think this is going to be an area where AI is going to improve year after year after year. And it might be a few years till we see the max benefits of it. But knowing that we have that problem, now we got to save our data and make it readily available. And you're right. Uh, Petabytes upon petabytes of data go into our infrastructure so that we can tap in and use this technology.
So, Renny, as it relates to public safety, in organizations like Western Fire Chiefs, what are DTN's primary goals and priorities out there?
Yeah, it's been great, and working with the Western Fire Chiefs has been certainly eye-opening and a great partnership for DTN. What we have seen is, um, I think there's been a real change in awareness in terms of who understands that wildfire risk is really as serious as it is. And so you've seen the public, the states, the organizations investing in whether it be, we'll call it a hardening or trying to prevent wildfires from becoming a problem. But I think further down the line, the impacts to the industries that are also impacted by this has been less. And I like to tell this story. When we started really ramping up our wildfire efforts, we had seen some of the major landmark, law cases and bankruptcy out west and some of the major utilities. And I actually went to some of our major customers in the eastern part of the US and said, "Hey, listen, are you guys thinking about wildfire? Uh, I think that this could become a growing problem and a growing risk to your business, to your shareholders, to whatever it might be." And kind of laughed and said, "We might get one wildfire every 50 years around here. It's not that big of a deal." And then about 2 or 3 years later, regulations started popping up. And those same people who kind of scoffed a little bit at the question are now it's top of mind for them. And so our partnership, while it says Western Fire Chiefs, I believe is to spread the message beyond just the West and ensure that everybody understands that wildfire is a growing concern. As we see warmer and drier climates, we're seeing more extremes in our weather. And as a result, um, it turns out that the places that maybe haven't had a type of weather problem in the past may have it in the future. We saw an amazing snowstorm go across the deep south this year that paralyzed them for several days. If you take that example and apply it to wildfire, while we need to be great in the areas that have them more frequently, there are other areas that are more infrequent. And so we're trying to help spread that message and provide a set of services that protects all rather than maybe some of the areas that have had a head start on it.
I notice, you work with a lot of utilities. You also work with ag ranching. You work with emergency management agencies, other government agencies. What are some of the things you do for them overall?
Yeah, so it all starts on essentially our main central concept is called a weather action plan. And so we like to look at the organizations that we work with and list out here are all the threats that disrupt, create safety concerns. If you're talking to a specific business, this may impact your budgeting or your bottom line. We work with a lot of organizations that have a set of regulatory governance that they need to follow and track should there be a threat that comes along the line. And so we start by consulting with an organization on do you have a weather action plan today or not? And if you do, let's talk about how we can refine and improve upon that. And if you don't, we'll actually provide guidance on what a weather action plan looks like. Then we have a whole suite of software and data products that essentially take that weather action plan and bring it to real life. And so we can start to state the risks that are out ahead of an organization. And if thresholds are clearly met, here's the action that they should take. We describe it as an operational decisioning platform. And so, for example, when we work with utilities, and it could be as extreme as a PSPS event, or even let's change our daily work orders around so that we're not either working in an environment where we may cause a fire or we need to harden some of our infrastructure and protect against creating one. We will have a clear list of variables and thresholds. And if those are met, then our customer will then know what action to take. And ultimately, we're giving them confidence in their decision making. Maybe it's the deployment of resources to understand that they can protect their risk and at the end of the day, protect their customers and their constituents as well. So it's a really integrated set of workflows and where the software, the apps, the data correspond with an organization's operational um, operating cadence. And as a result, we want to take the guesswork out of decisioning because look, when you're dealing with weather, we understand it's not an exact. It's not a promise that a fire is going to start today. It's not a promise that you'll get a thunderstorm. But should those risks become real, we want you to be able to take action really fast because seconds matter, minutes matter in these really high stress environments.
I find it kind of interesting, and we San Diego Gas and Electric actually started as a public safety power shutoffs. And when they first started, there were only two requirements: one when they were doing it, and two when they were turning it back on. I think today there's like 500 plus uh, things that they have to do, the checklist out there today. It's amazing where, you know, one organization started and it's kind of caught on, not only in the West, but it's making its way to the East quickly out there. But it's really amazing to watch how we're evolving.
Well, and it's great. I think if we're not in a constant learning environment, we're screwing up. And as I mentioned, when we start to work with an organization, they may have a weather action plan, and it may be very sort of a linear plan. If X occurs, Y happens. What we start to learn is that if X occurs and Y happens, you may actually introduce Z risk as a result of making that adjustment. And so you start to see these plans really expand to start to capture what you might describe early on as an edge case becomes a more common reality. When early on in my career, I was a professor at Mississippi State University, and we started, and it was a pretty new concept. I want to say it was probably around 2008 or 2009, called the Crisis Action Team, which was to develop a plan and communication system around all kinds of threats to campus, whether that's terrorism, if you have a shooter on campus. And somebody kind of thought, man, we should probably add weather, as a threat if a tornado were to come towards campus. Turns out after the first 5 years, we used weather to enact that 94% of the time. Okay, so weather was the number one threat, but that was kind of an afterthought at the beginning. And then we realized putting it in action that we needed to beef up that side of that plan. And I think that's true even in wildfire responses. If you can start with a simplified plan and start to reduce your risk, you then recognize there's even more decisions to be made, more data available to you, and you can strengthen that plan. The goal is to not have so much scope creep that you become paralyzed by the number of steps you need to take to make the decision. And that's something that you have to watch on the opposite end. If you have 500 steps in a plan, better make sure you can work through them quickly so you're not paralyzed by those steps.
So, Renny, I want to drag you down the private side, and then Chief Zeal drag you down the rabbit hole about on-site weather and how you guys integrate that. But you've mentioned in this conversation, some of your clients and customers, right? I think when I was a firefighter, I didn't get the importance of private industry to how I perform my job. To me, it was all chopping holes, spraying water, and shocking people, right? I forgot that I climbed on a fire engine someone had to build, and I used a cell phone someone had to build, and I used a radio someone had to build, and I'm wearing gear someone had to build. There is just this private interface that isn't obvious unless you think about it. And that's the case here. And I think one of the clearest examples to your typical chief officer is insurance. Like, the insurance companies canceling everybody and getting out of complete markets. They have their reasons for doing it, and that's another podcast. But I bet we could agree on one thing. The one thing insurance companies have in common is they were all wrong. What they thought the risk was is not what the risk was, and they're fleeing what they don't understand. Now, they're getting a handle on it now, but boy, it's been slow to happen. I have to assume that you have clients like insurance companies and other strategics that are making billion-dollar decisions based on your ability to analyze and predict trends. Can you give us a glimpse into what that's like for you and what kind of clients you may have?
That's an awesome question. Here's a really interesting thing, and this will be a little bit more generic than I'd love to give a specific example. But used to be when I started my career that we used the 30-year normal as the normal for weather. You'd see it on TV, you'd see it in agriculture, and then we realized that it wasn't capturing what was really happening the last 10 years. And so I think one major learning when working with organizations is we need to make sure we have the right representative sample in measuring what risk is. And then there's been a lot of emphasis on creating forward-looking projections on what the climate may look like 10 years from now or 15 years from now. And so we've been working in that aspect in private. And I think of it as there's short-term risk and there's long-term risk in this space. The short-term risk being what's going to happen over the next 15 days. And I need to be ready to respond right now to what's sort of the here and now in front of me. But the other aspect that we work with these large private organizations is we like to understand what their evolving profile of risk is for them in the future. And then if I'm going to make capital investment to harden my infrastructure, whatever those assets may be made of, I should diligently choose to not just make something look nice and pretty, but to actually help in creating the prevention of new risk down the line. And so we've seen this in all aspects. The utility is a great example, spending a lot of money on vegetation management, for example, and in those sort of easement pathways and making sure, even if you're talking about windstorms or fire, any of these perils where you've got trees close to power lines, maybe I should remove those out of the way. And that's an investment that I make to prevent a future problem down the road. And so we tend to work with organizations on that double risk, which is, let me think a little bit further down the road. What investment can I make today that reduces my risk in the future? And then the second one is, if there's imminent threat over the next 2 weeks, how am I going to respond to this right now? Do I need to bring equipment in? Do I bring extra crews or people in? And those are really expensive decisions. People are not cheap. Got to get hotel rooms and equipment. And so we do a lot of projection on impact of weather. I think the misconception, Jeff, is, as you said, when I tell people what I do, they think that we're just forecasting the weather. That's actually a pretty minor part of it. That part's pretty well understood. It's measuring the impact of that weather on the operation. And so a lot of our innovation is focused on impact-based guidance that says, because of this weather forecast, this will impact you in this way. And now you can adjust and be proactive in decisioning rather than, I hate reading in the news, it hit without warning. There's not a lot of times in this world where that needs to happen. And there is signals that a high impact event is on its way. And so that's what we're trying to focus on, is those two really core investment areas, kind of my operational day to day, and then how I deploy capital to harden infrastructure so that we can be ready to go. And I think insurance is intriguing, and it matches that in some regard because of the actuarial science looks so far back in history that it didn't see the change in climate as having more wildfires, or how is the vast amount of construction and expansion of urban creating new challenges that might not have existed 10 or 15 years ago. I think the Dallas Fort Worth metro area doubled in size in the last 10 years as an area. Well, I'm putting more things in the way, and I'm creating new infrastructure, and I'm changing the landscape. We have to constantly model how that's going to be to understand the risk, and then price everything accordingly.
Well, just the pavement changes the heat signature, right? Which changes.
Absolutely.
Right. That's amazing
Yep.
stuff.
Or increases the runoff. If we're not building into the wildland, and we're paving everything over, and it's just increasing the amount, the way the water is going to run out, and fire, flood, you take your pick.
Well, I get asked, like, are we, has climate change created more tornadoes? I think that's a fascinating question. Number one, I carry around a cell phone with me like everybody else does. If I see a tornado, I'm taking a picture of it today, right? There's very rarely one that occurs that nobody heard about. And then the second thing is, if I'm doubling the geographic scope and putting more assets in the way, those are more likely to get hit by these storms that may have been occurring all the time. And so there are aspects of humans have adjusted the environment, and therefore that makes things more risky when you put more, more money in the way of these hazards that have been occurring for a long time. And then I do think that there's been adjustments to the environment that is creating more hazards. There's not really wildfire season anymore. It's just wildfire, and can happen all year round. And that's been a big learning we've had as well, and a reason why we've started to see more investment. And there's a lot of investment right now in trying to understand wildfire risk and protection. And I think that's because they're occurring 12 months out of the year. We've got wildfires going on, and it's not just a few month season.
Yeah. So, I think I read on your website that DTN is recognized as Israel's cornerstone partner for weather intelligence. Can you speak a little bit about that?
Yeah, we were awarded the Cornerstone Award a couple years ago for the length of time that we've been a partner, over 20 years with Esri. Weather by nature is a very spatial concept. And so the idea of geographic information systems and being able to map assets along with weather has been a really important aspect of the way that we innovate. And so there's been so much core innovation and tools created with Esri and other technology companies that we like to take advantage of, and then ensure that we're integrating this data in as many places as can be found. The tech world's amazing to me, how fast it rapidly evolves. And that's something that we're trying to stay on the forefront of, whether it's AI, mapping, using the cloud. All of these different unique technologies allow us to be more accessible, more available, um, and maintain really high standards of operational, capacity that we have. It's really intriguing in our world. The amount our data gets used is there's real big peaks and valleys depending on what's going on with the weather. If it's just a quiet day across the country, not, not a lot of tech is needed on it on that given day. But if you've got really active weather with a hurricane bearing down, a blizzard in the north, a wildfire out west, and lightning in Florida, our stuff's getting hammered. And so we like to work with the tech partners to ensure that we're always on.
Chief Z, let's talk a little bit about, when you and I had a little less gray hair about how weather predictions are done on a wildfire, and kind of cover that, and let's talk about why it's different now and how you merge what Renny and his team at DTN are doing.
We don't do weather the way we do it today. I mean, we got the weather from local force, weather station. Um, if you're really in wildland back then, we had a belt weather kit. Our weather stations that we used to do things today. So, and that kind of, got us going. I mean, we all knew that, a nice hot day with low humidity and wind wasn't going to be a good mixture, but, not as many people were doing fuel moisture with, 1 hour, 10 hour, 100 hour, 1,000 hour fuels. So, those things have really changed considerably too.
It's incredible. As I came up through my meteorological education, I remember one of the first weather models ever created, and it kind of blew my mind that eventually we could predict where a thunderstorm would develop. Used to be you looked at really broad patterns, had an understanding of what those broad patterns would represent. Today, we're able to model at high resolution. And then when you add in the wildfire component, of course, the fuel moisture and the fuels available for fire become a really important concept. And then so does terrain. I think terrain is one of those things that people don't understand has a huge impact on a weather forecast because air is trying to find equilibrium. And so it wants to flow through valleys. You put trees in the way, that creates friction for that wind. And so you start to get little swirls. And so a lot of the technology today, and when we think about artificial intelligence in weather forecasting, is our ability to compute these complex mathematical and physics equations really rapidly over very short distances. And that gives us the chance to model the atmosphere and model the terrain in a way that makes weather forecasting a lot more precise and I think a lot more valuable versus, the old days of just putting up a stick with a wind vane on it and saying, well, my wind's out of the east today. That could be for a variety of factors. You could have a hill sitting over here that's making the wind in that little spot come out of the east where really the prevailing wind is out of the south everywhere else. And so we're trying to capture those nuances. The other amazing thing is to be able to go back and model history. And so not only are we looking at the forward view of the weather forecast and modeling out what we're expecting, but now we're doing 20 and 30-year reanalysis with this high resolution data to project what it looked like in history. And then the known fires and the known information that we have from the past, we can marry up. And I think that's really helping to improve a lot of the fire spread modeling and a lot of the scenario planning. I think that's some of the coolest technology is let's just pretend a fire occurred right here. Let's see where it would spread. I think there's so much amazing advancement going on with both the weather forecasting and the fire spread modeling right now.
I think, you know, government is years back had put a lot of money into remote automated weather stations. Um, but what's really transpired is the utilities have really, really increased the amount of automated weather stations we have out there. Um, Only followed by the amount of, alert cameras, California or the West that are out there. And, not only can the forecasters now, zero in on them in a, microclimate area, but they can also turn on the cameras and actually see what's going on as we get buildup. We used to laugh in the early days at Northern California along the coast, redwoods, and going into Oregon and Washington. It was like the asbestos forest. Well, those, if we saw in 2020, boy, we saw a lot of activity on the west side of the coastal range that we had not seen in quite some time. And we know, again, weather comes in off that coast, and yet on the east side of the coastal range kind of holds that in. And you know, how does all this automated weather and the cameras, how does that play into the forecasting you and everybody else is doing?
Yeah, it's really, really important. So, in order to make a great weather forecast, you have to have a really good understanding of what's happening right now. I think there's a bunch of technologies aiding into that. You've got the automated weather stations, which gives you a ground reading um, of the weather. We're starting to launch drones into the sky and get some of the you know, let's call it 1,000 feet or so into the atmosphere, because that's really important. Satellite technology is coming along really fast as well. And so, not only for measuring things like hotspots, but even just measuring the atmosphere itself. There used to be the only way to get a measurement of this would be to launch a weather balloon, and you'd do it twice a day, and they'd be 150 miles apart from each other. A lot happens between 150 miles. And so you thought you had an accurate reading, but between the satellites, drones, weather sensors, new radar technology, airplanes taking off and landing and the sensors they have, all of this information becomes the initialization for the models. And so we compute it all together. A lot of the special technology is what we call initialization. And so if I can initialize a model with the correct conditions at the beginning, then my forecast has a way higher likelihood of being correct in the future. If I'm starting with incomplete or inaccurate data at the starting point, I'll use cleaner language than I normally would, but crap in equals crap out in a model. And so we have to have really clean inputs into it. And that's where the sensors and the remote sensing, the cameras give us a material advantage to start getting the forecast right.
Yeah. You know, the National Weather Service, just has changed how we actually do things just recently. Um, I'm old school, and we used to say, lightning level 6, would be the worst that you could have, and we that's not a it's not terminology we're using today. Just recently changed. So, can you chat a little about lightning and how the new weather forecasting has changed in that respect?
Yeah, in terms of lightning specifically, there's a concept in weather. You can model weather in three different ways today. The first one would be like a global model, or we call it a synoptic model that looks at the weather pattern in general. Here's where the troughs are, the ridges are, low pressure, high pressure, etc. The second one is called convective allowing models, or CAMs. So convection, for people that wouldn't understand, I think most people probably heard that term that is listening to this, but is essentially where you get rising air into the atmosphere from heat buildup, and that's the beginning of thunderstorms. So a thunderstorm is generated through convection, and so a convective allowing model will actually model individual thunderstorms. And so from a lightning perspective, if I can model that I'm getting a little bit of hail production up in a cloud that creates charges, I could actually now model where I think lightning is going to develop a few hours before it does, which is really neat to look at. And then we have the artificial intelligence, which is looking at tens of thousands of simulations of the current weather with the past history weather to simulate what we think is going to happen over the next few hours. And so, lightning prediction from a forecasting standpoint is rapidly evolving. And then the networks for detecting lightning as it's occurring are really advancing as well. There's a lot of algorithms that are being developed so that we don't need to just put a sensor every mile by any means, but we can use algorithms to detect where we're seeing lightning charges build up and get on top of that. So um, all of these perils are really rapidly advancing pretty fast, and the lightning is coming along right along with it.
I went back in my early career with Bureau of Land Management, and we used to have fax machines, Jay. You appreciate this. And we used to have thermal paper. You'd have to put the paper in and put the phone down on top of the fax machine there. And, you know, they'd send you the information and go round and round and round and round. And then you'd have, positive and negative strikes on it. And then, you start taking a look at it. And I look at where we're at today, you know, technology wise, and pull up our phones and be able to see, where the strikes are. And, uh, you know, we've come a long ways.
The polarity, I mean, now you just about have to be about a 500-meter accuracy on lightning detection to even be considered as a good lightning detection system, which that's unbelievable to me. And if you see a lightning strike and see how wiggly they are and how they arc across the sky to get that precision is just amazing to me. And I'm curious from your guys' perspective, now having so much available technology and maybe hopefully growing confidence in a weather forecast versus there is something kind of romantic or feeling connected with the atmosphere, right? Being out there and sort of having to look and see and feel and understand. I think a wind shift might be coming or whatever threat is. How do you think that that has changed from the perspective of fighting and predicting fires? Do you think it's great having all this advanced information, or do you think that we're losing a little bit of that feel, that gut instinct from just having kind of be one with the atmosphere?
I think you're better if you blend them, right? Like any of us that are outdoors people, we know what an approaching weather storm smells like and feels like. You look at your friends and say, we better get out of here because it's about to get ugly. And that's before you see a cloud come over the ridge. I think there's some of that instinct that just requires hours in the field, but I just don't think you can beat the science that comes with what systems like DTN offers and the satellite analysis, et cetera. It's pairing them. It's no one alone is good enough. I think you have to pair them. I think the real challenge, Rennie, becomes especially in the remote environs where wildfires are occurring oftentimes is we don't have the ability yet to reliably 100% of the time move data from point A to point B. So you can be analyzing the heck out of it, but if we don't have a FirstNet deployable there or the FirstNet satellite, which are being deployed right now, if they're not in place, then getting the message to me and I'm the decision maker, that becomes a problem. So that's, FirstNet, which is one of the sponsors of the sponsor of Catching Wildfire. It's all about creating coverage, which FirstNet does. They're about adding towers. Of course, we're launching an entire packet of satellites that will allow it to talk directly to your phone. No towers, no cell over Wi-Fi, just right to your phone. That's a game changer for moving the kind of intelligence that you produce down to the decision makers. And I think that's the last gap because to your point, we're getting really good information. The algorithms are getting better and better. So now it's just about moving the data where it needs to be, when it needs to be.
I completely agree. We always say, what's a great forecast if it's not communicated? And if you're not able to get that information there, and we're producing so much data and so much speed to it. We've gotten our lightning alerting, for example, to where I can stand outside, watch the lightning flash, get the alert that the flash occurred, and then I hear the thunder. That's pretty amazing to me, but you got to be somewhere where you can receive that information. And so I agree with you. I think that's a huge set of continued investment and making sure we have constant connectivities is a big factor in this.
Technology is moving quickly. Again, it's how quickly we adapt to it. Some cases it can be overwhelming, so you really got to work at how many apps you can have up and still stay focused on what you're doing. But last year was actually teaching a strike team leader class for new strike team leaders, and we talked about things you should have on board, and one was that belt weather kit. What do we need that thing for? What's the technology we have? And I said, well, sometimes you may not have technology. The old ways are still the good ways. And like JJ was saying, you can feel the weather. Um, but, you know, we just why we convert to use of technology, we also need to maintain, how we gathered it and how we still do it. Because at some point, technology will fail or may not be there at that particular time, or it may not be able to push it, uh, on that bandwidth for some reason.
I think it was very eye-opening, especially for us in the weather industry last year, the floods in Texas, and, that's a huge recognition to us that we can forecast all the rainfall in the world, um, but communication didn't get to the people that needed it the most in that scenario, and so there was a breakdown between forecasting capabilities and our ability to connect with people that needed to know, and so um, there's got to be. That's why I asked the question. The gut instinct and the ability to understand and feel what's going on around you, paired with technology, is a great combo. But if you only rely on the technology, it can fail from time to time, and I think that's when major disasters tend to happen. And so, even in the world of meteorology, we've got to continuously even teach our young and upcoming forecasters to still look out the window and still observe what's going on with the weather around them, and not just trust these models that create it. As great as they are, there's still a human element of forecasting that matters in these really impactful environments.
What gives you optimism as you look at this world? What gives you optimism about the intersection of weather, the science of weather, and wildfire as you look into the future?
What gives me optimism is that what I discussed earlier is we're moving into the impact. I think the tech revolution is going to allow us to not just accurately forecast weather, not just accurately forecast wildfire, but we can go and look at the impact of it. I don't think we're very far away in the next 3 to 5 years of saying this individual house or pole or whatever you want to name the asset is under a real threat, and we can create a much safer environment. What I'm most intrigued by is the projections that get into the seasonal, subseasonal, seasonal, and climate, and continuing to improve out to where we can get to a high state of prevention above just reaction. And I think the world's thinking that way. I think there is a lot of really smart people, including the two gentlemen that I get to interact with today, that are really talking with the right stakeholders, putting the right investment into all of these aspects, and learning from, I had to do it this way years ago. Let's do it a better way tomorrow. And if we all put all of our intelligence and smarts and technology and people at the problem, it's a problem we're going to tackle. And that's what gives me optimism, is that there's investment, there's technology, and amazing people working on the problems to solve.
JJ got one more for us.
Go for it.
They say this is going to be the worst El Nino in 140 years.
My thoughts, to be matter of fact, is that when you have a signal that is that strong, that actually makes things way more predictable than if we didn't have a signal. Where weather forecasting, and especially in the long range, um, gets hard is when there's sort of noise in the signal, and when you have a really strong extreme in one way or the other, it makes things quite predictable. I'll tell you, I think it's good news for the tropical season. I think we will have quite a few less hurricanes than we have the past few years as a result, but it's going to make things quite windy on the West Coast, and that might not be the greatest thing for a wildfire. So I think the predictability is going to go up. But we'll see. It's still a ways out to see if we get to a strong El Nino, but all signs are pointing towards it being a really strong one.
As I prepared for today, I was just thinking, you guys have great titles. You got the National Treasure. You're right. You have the General Manager of Weather Intelligence, and the third one. I don't think there were ever better titles, and I'm envious. I want to thank Renny Vandeweg from DTN and Chief Zagaras for joining us on Catching Wildfire, and FirstNet, of course, for their sponsorship and helping us get the word out about things that matter to the fire service. Thank you both for your time and your insight today. Renny, thank you for the vision of being a partner with fire community and the Western Fire Chiefs. You guys have been an amazing partner. So thank you both for joining Catching Wildfire.